Hello students, welcome to the physics class. Today we are going to solve NEET question paper. So let us start. It starts with 91 because from 1 to 90 it was biology, and now we are starting with physics. So this is a 2012 question paper. Let us see one by one. The first question says, two metallic sphere of radii 1 centimeter and 3 centimeter are given charges of -1 into 10 to the power -2 coulomb and 5 into 10 to the power -2 coulomb respectively. If these are connected by a conducting wire, the final charge on the bigger sphere is. So this is a question came from the chapter current electricity, and the concept of capacitance they have used. Okay, so actually it is the concept of capacitance, mostly capacitance on a spherical body we will be using here. So what you will do? So you know that the common potential V is equals to Q1 plus Q2 divided by C1 plus C2, right? This is what the common potential formula is. You need to use this formula, and you have to know one more formula, that is the capacitance on a spherical body. That derivation is done for you. Look for the videos, you will find there. So right answer for this question is question number 3, which is 3 into 10 to the power -2 coulomb, right? So this is the right answer for this one. Now let us move to the next question, that is question number 92. A proton carrying 1 mega electron volt kinetic energy is moving in a circular path of radius r in uniform magnetic field. What should be the energy of the alpha particle to describe a circle of same radius in the same field? So which formula you are going to use out here? So you will be using QB R is equal to root over of twice m of energy, that is the kinetic energy. So you need to find out the ratio, you need to find out the energy of the alpha particle. So for that you need to find out the radius at first. So if you know this, capital letter B or small letter, capital letter Q or small letter q, doesn't matter, it's the charge only. So with the help of this formula you can initiate, and you will find that the correct answer for this question is coming out to be 1 mega electron volt. So number 3 is the right answer. Now let us move to the next question, that is question number 93. A circular platform is mounted on a frictionless vertical axle. Its radius r is equals to 2 meter and its moment of inertia about the axle is 200 kg meter square. It is initially at rest. A 50 kg mass stands on the edge of the platform and begins to walk along the edge at the speed of 1 meter per second. Relative to the ground, time taken by the man to complete one revolution is how much? It's a circular platform. There is saying that we have a circular platform which is mounted on a frictionless vertical axle. Its radius is given to us, and its moment of inertia about the axle is also given to us. It was initially not moving, it was at rest. Now a man of 50 kg stand on the edge of the platform, and he begins to walk along the edge, and he has got speed in his body, that is 1 meter per second. That is in relative to the ground. Now you need to calculate the time taken by the man to complete one revolution. So you have to use the concept of angular momentum out here. If you use the concept of angular momentum, you will see that the correct answer for this question is coming out to be 2 pi seconds. So option number 4 is the right answer for this question. This is a question came from the chapter system of rotational bodies. Option number 4 is the correct answer. So now let us move to the next question, that is question number 94. Number 94, it says that the ratio of amplitude of magnetic field to the amplitude of electric field for an electromagnetic wave propagating in vacuum is equal to how much? So this is a question came from the chapter electromagnetic waves, where the right answer for this question is the reciprocal of the speed of light. If you see the ratio, you will see that the right answer for this one is reciprocal of speed of light. So correct answer for this one is option number 3. This is the right answer. Now let us move to the next question, that is question number 95. A A magnetic needle suspended parallel to a magnetic field requires root 3 joule of work to turn it through 60 degree. Okay, a magnetic needle is there which is suspended in parallel to the magnetic field. Okay, it requires a work of 3 joule, that is root 3 joule, to turn it through an angle of 60 degree. Parallel means what? It was initially at 0 degree with the magnetic field. The torque required to maintain the needle in the position will be how much? Okay. Now, how do you find this one? First of all, you need to know that the work done is nothing but the change in energy, that is the final energy minus the initial energy. And how do you calculate the energy? We have the direct formula mb cos of theta 2 minus mb cos of theta 1. Now, if you know this, torque formula is very simple, mb sin of theta. So, once you find out the mb from here, if you calculate the mb, you can put it here and theta is given to you, right. So, the correct answer, if you solve this one, which is from the chapter magnetic effects of current, the right answer will be 3 joule. This is the right answer. Fine. Now, let us move to the next question, that is question number 96. A rod of length 10 centimeter lies along the principal axis of a concave mirror of focal length 10 centimeter in such a way that its end closer to the pole is 20 centimeter away from the mirror. Find the length of the image. It is a very good question. The question says that, I will make you understand the question. You have a concave mirror, suppose this is the pole of the mirror. A rod of 10 centimeter length lies on the principal axis. Suppose I have a rod of 10 centimeter length, this is 10 centimeter, fine. So, from here the distance, the end which is closer to the pole is this much. This is how much given to me? It is given 20 centimeter away. And the length of the focal length is given how much? Focal length is given to be 10 centimeter, that is minus 10 centimeter, right. So, once you know this, what you can do, you can find out the image distance. There will be two image distance, my dear. So, you will find out for this one maybe V1 and for this point is V2. You can use the formula 1 by V minus 1 by U is equals to 1 by F. Once you find this one, then V2 minus V1 will give you the length of the image, but out here it is U1, sorry, this is U1 and this is U2, U1 and U2. The image will form somewhere. So, for finding the length of the image, you have to do V2 minus V1. If you do this, your answer will come out to be 5 centimeter. This is the right answer. Fine. So, try this and find the correct answer. Okay, this is a question came from the chapter optics, ray optics. Now, let us move to the next question, question number 97. The moment of inertia of uniform circular disc is maximum about an axis perpendicular to the disc and passing through which point? Where will be the moment of inertia which will be maximum for a uniform circular disc, the disc which is drawn on the screen, as you can see. Now, you need to check out which one has got the highest radius. Now, if you calculate A is at the origin, D, it is fine, it has got some radius, C, it has got some radius, but if you look at B, it has got the highest radius compared to other of them. So, the length, or I can say the radius from the origin till B is more compared to others. So, the right answer for this question is answer number 2, that is B. And this question came from the chapter system of rotational bodies of class 11. So, option number B is the correct answer. Now, let us move to the next question, that is question number 98. Which of the following plots represent the variation of gravitational field on a particle with distance r due to a thin spherical shell of radius r? So, r is measured from the center of the spherical shell. Okay. So r is the distance where the distance keeps on increasing. Suppose I have a spherical shell here. From here, suppose this is a distance r. Here it is not saying that the r is the radius. This one will be the radius of the earth. Fine. So what is the formula? Formula is if you calculate what you are going to calculate out here, gravitational field, right? So it will be K, that is G m by r square. So if there are r, that will be r plus r, G m by, you can say directly r square, because it is calculated from the center of the sphere. It is saying in the question itself. So as you increase the value of r, the field keeps on decreasing, that is the gravitational field, right. So my answer will be option number 3, that is the decrement of the field with the increase in r, the distance. So right answer is number 3. Now let us move to the next question, that is question number 99. Question number 99 says, you clearly see that this is a gate, right. This question came from the chapter Semiconductor Physics of class 12. So how you are going to solve this one? To get an output y equals to 1 in given circuit, which of the following input will be correct? You need a output 1, fine, and from the options only you need to check which one will be the correct answer. Now let us see the options here and let us identify the gates. So we have two gates out here, one is OR gate, the other one is AND gate. So if you look at the OR gate, the output options will be how much? Now see here, this is A and this is B. So if you take 0 and 1, from OR gate you will get out here will be 1. So first option will be 1 and from here it will be 0. So final answer will be 0, right. So now you check on this one, 1 and 0. If you take A equals to 1, B equals to 0, then again you will get 0 out here and out here is 0. 1 and 0 will be 1 and out here is 0. So the final output is again going to be 0. Now you check on number 3, 1 and 0 and again 1 for C. So A and B will be 1 and then from C also it is coming out to be 1. So AND gate, what it will give? 1 into 1 will be equals to 1, that is A dot B will be your output from the final one. So this is the right answer, option number 3. So 99, number 3 is the correct answer. Now let us move to the next question. A parallel plate capacitor has a uniform electric field in the sphere between the plates. If the distance between the plate is d and area of each plate is A, the energy stored in the capacitor is. Now which formula you are going to use? This is a question again came from the chapter electrostatic potential and capacitance, and the energy stored in the capacitance is given by E equals to half C phi square, and we know for a parallel plate capacitance C is equal to epsilon naught A by D, and V can be written as electric field multiplied with the distance between the two plates square. Now if I take half epsilon naught A by D, E square D square, so d get cancel out. Your final answer for this one is coming out to be, oh, I have shown you the whole answer out here. So it will be half E square epsilon naught A, fine, and D will also be there, D will be there. So check out for the correct answer. I think the correct answer for this one is option number 4. So 4 is the correct answer. You can click on 4. Fine. Now let us move to the next question, that is question number 102. The power dissipated in the circuit shown in the figure is 30 watt. How much is the power given? 30 watt. The value of R is how much? Okay. You need to use the formula for power out here. What is power? P is equals to VI. Fine. So P you know, V you know. You can calculate the current from here. Okay. Once you know the current, you need to find out the resistance, right? Again, you can use this formula V equals to IR. But out here R is in parallel, capital R is in parallel. So I will write down R dash, take the parallel combination and find the answer. You have to start with the P equals to VI. Or you can use P equals to I square R, but you need to know the value of current at first. So my dear students, this question came from the chapter, I will say, which one? Current. So with the help of this circuit, you can find it out. So the right answer for this question is 10 ohm. Option number 4. So option number 4 is the correct answer. Option number 4. Fine. So now let us move to the next question, that is question number 103. If VE is escape velocity and V0 is orbital velocity of the satellite for orbit close to the Earth's surface, then these are related by what? So this is a question came from the chapter Gravitation of class 11, a direct question, and we know that the escape velocity is equals to root 2 of orbital velocity. Please see the expression in the video which was done. Please take out the chapter and study it very nicely. You will see that this relation is directly given. So I will say this option is the correct answer. A stone is dropped from a height h if it hits the ground with a certain momentum p. If the same stone is dropped from a height 100% more than the previous height, means if the previous height was h, then the new height will be twice of h. The momentum when it hits the ground will change by how much? So as we know that this is a common question with general knowledge of physics, you can solve this one. Momentum is directly proportional to the height, to the root over of height h. So if I take P1, it will be root over of h1. If I take P2, it will be root over of h2. So P1 by P2, I will write down here P1 divided by P2 will be equal to root over of h1 by h2. So as the question says, it will be h divided by twice of h. So your P2 will be equals to root 2 of P1. Now if you start taking the percentage out of it, the correct answer for this question will be option number 3, that is 41%. I almost solved 90% for you, just you need to calculate the percentage. Now let us move to the next question, that is question number 105. An ideal gas goes from state A to state B via 3 different processes as indicated in the PV diagram. Okay. If Q1, Q2, Q3 indicate the heat absorbed by the gas along the processes, along the 3 processes, and delta U1, delta U2, delta U3 indicate the change in internal energy along the process respectively, then which one will be the correct option? So A to B, it is coming back to B, 2 is also coming back to B, 3 has taken different path but coming back to B. So out here the Q1 will have more than Q2, Q1 will be more than Q2, Q2 will be more than that of Q3. So this is a question came from the chapter Thermodynamics. So you have to see the PV diagram, and the internal energy as it is coming back to the state B, all of them will be same for all of them, right. It is done, PV diagram is made for a constant temperature. Okay. If the constant temperature is same, then the internal energy will also be same for all of them. So the right answer for this question is option number 2. This is the correct answer.
So which of the following reaction is appropriate for converting acetamide to methanamide? So this question is come from your nitrogen containing compound from your class 12 NCERT, and if you see the correct option, Hoffman bromamide is the correct answer.